In this tutorial, we'll be learning how to look at statistical significance in SPSS. We don't actually have to learn any new procedures to do this. What we need to learn is where to look at the output that we've already been producing. Let's first start with a crosstab, and we'll be using GSS data here. Okay. Sort these properly. What we're going to be doing is taking a look at party identification. There's a variable here called party ID2. Put that in our dependent variable box. And we're going to be looking at the effect of race on partisanship. We want to know whether there's blacks and whites have different levels or different patterns of party identification. Let's see, and our variable here is called race. Okay, so let's place that in there. As normal, we can ask for our column percentages. We go up for our statistics. We ask for Kramer's V and lambda. And here's one additional statistic you can ask for to assess statistical significance, and that's chi-square. So you might want to click that as well. Hit continue. Hit OK. Bring up our output. Okay. Now everything looks just about the same as it did before. We have one new box because we clicked chi-square, and that shows up here. What chi-square assesses is the overall statistical significance of the crosstab. And it does it without really producing any measure of association. What it does is it produces a test statistic that is the chi-square statistic. 189 here is the value of that. And it turns that into a p-value, which is over here. And you'll see this is called, you'll see throughout SPSS that the p-value is usually indicated by SIG period, SIG. Or here it says asymptotic significance or approximate significance. Wherever you see that, that's your p-value. Now, what you'll see here is something that we're going to come back to. 0.000. This doesn't mean that the p-value is 0. That would mean there's 0 probability that we're engaging in type 1 error. But that probability is never 0. There is always some possibility that type 1 error is occurring. So what the 000 actually means is that the p-value is less than 0.001, and SPSS isn't going to bother reporting the exact value because it's so small. So you can pretend that it's only produced the first 3 digits of something that might go 000005 or whatever, 0001. So what we can take this as is statistical significance at the 0.001 level. We can't report the precise p-value, but we can determine that it is statistically significant at that highest level that we look for. Okay. If you go down and look at your lambda value here also produces a statistical significance value. Now lambda, because it does some weird things, oftentimes doesn't tell the same story as chi-square. So it's interesting to compare those and useful, I think, to include chi-square tests when you look at a crosstab. You can also, of course, go down and look at Kramer's V, which produces a value here of 0.184, and then also has a statistical significance level, which in this case is below 0.001, and so it is statistically significant at the 0.001 level. Now you'll note that usually chi-square and the significance for Kramer's V, and the same is true for gamma, are usually going to coincide. Lambda is often a little bit odd in this regard, so it's good to have that chi-square to make a comparison. Now if we redo this with a control variable, it's more or less the same thing. Let's add in ideology as a control variable. That's right there. And go ahead and produce our output. And of course, as usual, it produces our crosstab for each category of our control variable, ideology. All right. We can go down and take a look at what happens. Oops. Let's go back up to bouncing around here. Stop. Here, let's go. Here's the chi-square tests. As you can see here, it produces this chi-squared value here for this crosstab, which is among the extremely liberal category. 7.5. It has a p-value of 0.271, so this is not statistically significant. The same is true for the liberal category. The same is true for the slightly liberal category. Neither of those are less than 0.05, and so they're not statistically significant. But then once we move moderate and to the right, we find that the relationship between race and party identification is statistically significant. Now, if we look at the lambda statistics, we find that we're getting a lot of zeros here because of that problem with lambda. So let's just scroll all the way down to Cramer's V and take a look at it as well. And it tells the same story as the chi-squared values. It's not statistically significant among the extremely liberal, the liberal, or the slightly liberal. The p-values are too large. The probability of a type 1 error is too large. So we have to accept that null hypothesis that there's no relationship between race and partisanship for those categories of ideology. Above that, or on the moderate to the right side of the control variable, we do see a continued statistically significant relationship between race and partisanship. Now I want to point something out here, which is the effect of sample size is evident here. If you look here at this Cramer's V of 0.191, it's not statistically significant. But then if you come down and you look at this Cramer's V over here in the category of moderates, Cramer's V of 0.182, which is smaller, is statistically significant at the 0.001 level. Why is that? How come a smaller Cramer's V value is not significant and a larger one, a smaller one is significant and a larger one is not? Well, the answer is here in the sample size. For this crosstab, this sub-crosstab, among only the extremely liberal, we only have 104 people. There are only 104 people who answered extremely liberal, and so there's only 104 there. Whereas for the moderates, there were over 1,000 people who said moderate, and so we have a large sample size. And because sample size affects the standard error, affects the size of the confidence interval, this is what can happen in a crosstab. And one of the reasons why crosstab is difficult to use when you start using too many variables with too many categories and you start slicing and dicing the sample up too small, you end up with too few cases in any particular crosstab to really have any confidence about the statistical significance of the results. Okay, let's take a look at correlation analysis and how we would assess statistical significance with that. And for that, we'll turn to the countries data set. And let's pull up our correlation menu here. And what we're going to look at today is kind of a slightly different question. What influences cigarette usage in a population in a country? And so what we'll do quickly is a little bit of a correlation analysis. We'll put cigarette consumption per capita there. And then we're going to have a number of variables we're going to put in this model. This is the percentage of the population below the poverty level. We'll have a variable for population density, one for the literacy rate, and then one for the GDP, economic performance. Oops. Okay. Hit OK. You don't need to change any of the settings. The default settings produce what you want. We'll come and look at our correlation now. Now, what we have here in each of our cells is our Pearson R correlation, and then you can see that the next row is the statistical significance. Again, that's the p-value, right? And then they also have the sample size here. Now, one of the things that happens with the correlation analysis is they produce these little stars here, and so they tell you exactly what level of statistical significance is reached by these, or at least it tells you if you've got one at the 0.1 level. It would add a single star if you had something that was only significant at the 0.05 level, 0.05 level. And it does not give you an additional star for the 0.01, although that sometimes is reported in research results. So you just focus in on this p-value here, right? P-value here, right? So you would say this is statistically significant, this one is not statistically significant, this correlation is, okay? So that's all you really need to focus on within the correlation is this p-value here, and that helps you determine the level. Okay, let's take a look at regression using these same variables. Cigarette consumption is our dependent variable. We'll stick these other variables in the model here as independent variables. Poverty rate, population density, literacy rate, and the gross domestic product. Okay. All right, let's scroll down. Well, first of all, you get this ANOVA box, and I promised you earlier we'd talk about this more. This is an overall a test of statistical significance for all of the variables as a set. Do they explain, the null hypothesis, I guess, is the way to say this. The null hypothesis is that the variables as a set don't explain any of the variation in the dependent variable. And the test statistic produced is an F statistic, and it produces a level of statistical significance over here. And generally speaking, if you have one variable in the model that's significant, you're going to get statistically significant F-test. But sometimes where this is useful is if you have a lot of what we call multicollinearity, where the independent variables are all related to one another. So once you control for the other ones, none of them end up being statistically significant. But then you look at the F statistic and its p-value, and you see that as a set, they do explain some of the variation, even though each of the individual variables may not. So sometimes that's useful when you have problems with multicollinearity. More useful, though, are the individual significance levels, the p-values for the individual regression coefficients. So here, if we look at the population, the population below the poverty line, we get our regression coefficient here. Actually, you get your standard error reported here, which again reflects the size of your sample and the variability in your variable here. And then you get your t-value, your test statistics reported. And generally speaking, if it's going to be greater than 2, absolute value of 2, it's going to be statistically significant at the 0.05 level. And you can see here that this has a p-value of 0.035, so that is significant at the 0.05 level. If we look at population density, we get the regression coefficient, we see its standard error, and we see the t-value, which is just that divided by that. And again, this is too small, so we're going to already see it's not even close to 2, and in fact our p-value is 0.747, so we're definitely going to accept the null hypothesis that there's no relationship in the population. If we look at the literacy rate, there's our coefficient, standard error, t-value, and this is significant at the 0.01 level. Remember, here's a p-value of 0.001, so it's not less than 0.001, so the best we can say is that it's significant at the 0.01 level. And then finally, GDP produces a t-statistic here, a test statistic of 2.6, and this is statistically significant at the 0.01 level. So again, the sig here is our indication of our p-value, which is our probability of type 1 error.